Okay, a couple of specific examples using the angle addition postulate. So first of all, it's telling you the angle DEF is a straight angle. What they're doing here is telling you that that's actually a straight line, and so you know that that's 180 degrees. It's not just a little teeny bit off where it's like 178 degrees, or just a little bit over 180 where it'd be 182 or something. So we know that that's a straight line. So first of all, I'm going to write the angle addition postulate equation, which is the measure of angle DEC plus the measure of angle CEF is equal to the measure of the whole entire angle, which is the measure of angle DEF. Now we know that that is a straight angle, so we know it's going to be 180 degrees. So 11x minus 12 plus 2x plus 10 is equal to 180. We've got 11x minus 2 equals 180, or 13x, or 13x equals 182, and x equals 14. So if we plug that back in, 11 times 14 minus 12 will give us 142 for that angle measure. I'll move that over a little bit because I'm kind of out of room. And then this one is 2x plus 10, so 2 times 14 plus 10 would be 38. Now notice that it's a good thing. We always want to kind of double check that our numbers make sense. When you add those together, you get 180, which is what we were trying to get, because again, it's a straight line. Okay, next example. This time it tells you that the big angle measure is a right angle. So being a right angle, that means that it's a 90-degree angle. Now again, we're never going to assume that angles that appear to be right angles really are. The way that you show a right angle on the picture is with this little kind of box in the corner of the angle. So that can either mean that the segments or lines or rays are perpendicular, or it can mean that it's a right angle. It's kind of the same idea. Okay, so this time, again, just to practice, the measure of angle JKM plus the measure of angle MKL, so JKM plus MKL is equal to the measure of the big angle, which is JKL, the measure of angle JKL. Now again, notice that we're putting the little measure in front of here because we have an equal sign and a plus, and that's what you use with numbers. So we're actually adding numbers together. Okay, so substituting in, we have 12x plus 3 plus 6x minus 3 is equal to 90. So 18x and our 3 and negative 3 actually drop out, equals 90, and it gives us x equals 5. Okay, we'll plug that back in. 12 times 5 plus 3 is 63 degrees. And 6 times 5 minus 3 would be 30 minus 3 is 27 degrees. We're going to do a quick little check and make sure everything looks good. That adds up to 90 degrees, which is what we knew because it was a right angle. All right, last definition and one more example. An angled bisector. Okay, an angled bisector is a ray. Now, it can actually be a line or a plane or something else, but usually it's a ray that divides an angle into two congruent angles. So it doesn't just split it up into two parts, it makes the two parts congruent. Now, when you're showing angles congruent on a picture, you put these little arcs on it to show that they're the same. If you had two pairs of angles in the diagram that were congruent, so let's say you had a picture over here, you had another angle bisector, and those two are congruent, but they're not the same as the first, we would do that. And we kind of offset these. Oops. We kind of offset these so that they're not kind of running into each other. I don't really like the way they did it on this picture over here, but what they were intending to show is that those angles are congruent. Okay, so in this picture, ray YW is an angle bisector because those two angles are congruent. So that would be angle XYW and angle WYZ. Okay, last example. In the figure, ray KJ and ray KM are opposite rays. So again, that's basically just telling you that that makes a straight line. Okay, they're just telling you that's a straight line. KN bisects angle JKL. Okay, KN, ray KN, is bisecting angle JKL. JKL is this angle right here. Okay, so if it's a bisector, that means that these two angles are congruent to each other. If the measure of angle JKN, which is over here 8x minus 13, and the measure of angle NKL, which is 6x plus 11, find the measure of angle JKN. Well, because we know it's a bisector, it forms two congruent angles. Now, we don't know the measure of this big angle, so we can't really do an angle addition postulate kind of idea because we don't know if you added up this angle plus that angle, what it would actually equal, other than the expressions added together. So we don't have a number or another expression to make it equal to, so it's not going to work to try to add them together. So we're just going to make them equal to each other. So we've got 6x plus 11 is equal to 8x minus 13. Again, because it's a bisector. So 2x equals 24, x equals 12. And then it asked you for the measure of angle JKN. And JKN is 8x minus 13. So 8 times 12 minus 13. 96 minus 13 should be 83 degrees. Now you can always double check. So this is 83 degrees right here. You can always double check that if you put in 12 on this one, 6 times 12 would be 72, plus 11 is also 83. And that's excellent because we knew that these angles were supposed to be congruent to each other. This is the end of lesson 1-4.